So firstly, I'd like to welcome you all to this evening's virtual tour of Duck End Barns. It's a Passivhaus Plus project in Drayton. So just 5 miles outside of Cambridge. It's a modern detached house that was formerly part of a farm. So in obviously very much in the rural end of Cambridgeshire. But it's now the home of Michael and Stephen, and it's very much become their forever home. Now, the opportunity to progress with the project overall was really only possible once their busy and stressful careers had finished, and therefore they were able to give some time to really put into the project as a whole, and give that time to the project overall, and also to enjoy their new home now it is completed. Tonight we've got 2 speakers or 2 elements. Firstly, Stephen is going to join us, or is here. He's going to join us and he's going to share the details of the project, a little bit about the brief, and where it's got to. Unfortunately, his partner Michael is not able to join us. He's out training their Labrador Jasper, and it's taking him out to have some dog training classes. So it's just Stephen with us tonight. And then after that, we'll be joined by Apos, their associate architect at Archangel, who obviously was the architect for the project, and he'll go into a little bit more detail about the Passivehaus and some of the other detail around the project. So I say there'll be Q&A after both Stephen's and Apos's sections. So just put them in the chat, and they'll be pulled together, and we will try and get through as many as we possibly can. So, but without further ado, I will pass you on to Stephen.
Okay, thanks very much indeed, Will. Can I just correct you on one point you raised? We haven't actually moved into Duck End as yet. Whilst we live in Drayton, we live on the other side of the village. We hopefully will be able to move into the new home probably around about the end of November, beginning of December, all being well in time to celebrate Christmas and New Year 2024-25. Thanks very much indeed for giving me giving us the opportunity to talk about Duck End. I'm going to look at this, or the intro, by looking at the 4 questions which over the period of the project Michael and I have been asked. The first one is, why an eco home? The second one is, why a passive house? Why would we want to stay in Drayton? Why would we want to build it in a relatively expensive area where land tends to be at a premium? What unexpected issues or differences have there been, or have we encountered throughout the project? So just addressing the first one, why an eco home? First of all, when we're all aware that the increasing cost of resources is having a tremendous impact on us, and this actually made us consider the options which were open to us to both conserve resources as well as reduce the running costs of a home. Some 20 odd years ago, we had a house built in Germany, and whilst that wasn't designed as a low energy home, it was of a considerably higher standard from the point of view of construction and insulation than the property in which I'm at the moment. And this made us think, taking the German example in mind, it demonstrated to Michael and to me what could be done, what could be achieved if the focus and objectives of the construction, in fact, the brief in general, were correct. So if we decided that we're going to have an eco home, why would we decide to have a passive house? Well, the first thing is that we did consider briefly a low energy home, but dismissed this in favor of a passive house, as a passive house provides a standard against which the performance of the house can be measured. And I know that Apos will cover this off during his term. But what is actually meant by a passive house? The term is used to describe, a building for which thermal comfort can be achieved solely by post-heating of the fresh air mass, which is required to achieve sufficient indoor quality conditions without the need for additional recirculation of air. So basically, what we're talking about is the movement of air throughout the house, stale air going out of the building, and the warmth within that stale air heating the fresh air which is coming into the building sounds very, very simple in practice, in theory. However, what does this actually mean in practice? Well, compared to a standard bricks and mortar house, the design of a passive house is considerably more complex, as there are many interacting and integrated factors which must be taken into consideration. Again, this is a point which I know Apos is going to cover off. The complexity of the design will increase costs, both from the point of view of design and also construction. And I mentioned this exchange of heat from the stale air and the fresh air. Well, that's achieved using something which I didn't know existed until we started this project, but that's an MVHR, mechanical ventilation heat recovery system. And that is a damn great box which sits in a plant room, and it takes up a lot of space. And you also have to take into account what other equipment is required. We have ground source heat pumps. Now, sorry, a ground source heat pump that is that's taking up quite a lot of space. We're fortunate in as much as we have a lot of land at Duck End, but nevertheless, we chose to use bores as opposed to a spiral. Had it been a spiral, then we'd have been looking at probably about 1.5 kilometers of tubing within the ground. So, and despite the increased costs and complexity of the project, at least in the initial stages, we're optimistic that the future running costs of the house will be low, particularly given the size of the property. And again, this is something which Apos will cover off in his talk. So why Drayton? Well, as you can see from the background that I've got up behind me, the village is quite rural. It's a small village located around about 5 miles from Cambridge city centre. Small, it has a population of around about 650 to 700. It's quite a quiet village, although the nearby A14 can be a little intrusive on occasions. However, the fact that the A14 is nearby also provides excellent connectivity. And I'm not doing a pitch for the village. I'm not trying to sell the place, but it's a very convenient place to live. Michael and I are in Drayton because we left London some 30 odd years ago with the intention of actually having a house built. But unfortunately, for various reasons, this never happened, although we did find a plot. And had we proceeded with that plot, it would now be under the A428 around Camborne. And so we ended up, because the idea of building fell through at that time, we decided to go for a new build house, which is where we are at the moment, but we have the intention of it being a temporary solution until we found something a little more suitable. And that would also be included moving out of the village. Some 30 odd years later, we're still in the village, and so I think that Drayton has proven to be more than suitable on this over the time. The last question that I've got, or penultimate in fact, because I'm going to add one more. What unexpected issues of differences have there been in the project? And by that, I'm comparing it with what we did in Germany 20 odd years ago, or what I've seen constructed in conventional houses. Well, as I alluded to earlier on, the sheer size of some of the pieces of equipment needed for the house and the associated space which they take up, that is something which needs to be considered. The complexity of the M&E systems, so mechanical and electrical systems, and the house control systems, the BMS. In this project, I've learned so many acronyms of which I was not aware beforehand. That's quite mind-blowing. Also, I've been introduced to, and we've engaged consultants whose roles, excuse me, I'd never come across previously, but these people have proven to be very, very important and instrumental in helping us to achieve our objectives. And yes, in true grand design style, the project has worked out more expensive than we had originally envisaged. But I think it's fair to say, and again, Apos may touch on this, but some of the increase has been due to the types of fixtures and fittings which Michael and I have specified in the actual building. And so last but by no means least, would we do it again? as was alluded to when we started this presentation, Duck M Barnes is intended to be the forever home for Michael and me. And so I sincerely hope that we don't have to do it again, despite the fact it's been great fun. And that's my bit. Anybody have any questions?
Yeah, there's one question from Sheila and Niall saying, what sort of consultants did you need? What do you need them for?
Oh gosh, there's a whole raft of consultants, and I think you cover those off at the end, don't you, Apos, in your presentation?
Yes, I have a slide showing most of them. I think it would be important to say which ones are relevant to the eco home part of the build.
Yeah.
Besides myself and Archangel, which is the architect and certified passive house designer, there's also a service engineer with good knowledge of low energy buildings, green gauge. There is an automation and AV specialist that helps with a building management system, or BMS aspect of a house, how the house can understand what's happening and react. So Stephen and Michael don't have to manually go and adjust things. But also the certifier, which is also an important a stakeholder in the process to make sure that things are actually built as they're supposed to be built.
Yeah.
There's one more question. How much, from Mark, how much did you project manage yourself, and what would you do differently with hindsight?
Wow. From a day-to-day project management basis, very little. We paid people to do that. Changes we would make with hindsight, as I think is actually in the summary that's on Cambridge Carbon Footprint for this presentation. The only change that we would have made would be to have lengthened two of the wings, or the two wings, and Apos will talk about the design of the house. But I think we would probably have increased the length of the two wings to give a little bit more space in the bedrooms. But that's all. We were constrained to some extent by planning on the volume of the house that was going to be constructed, or the volume of the properties which were going to be constructed on site, because it's not just one house. There are 4 buildings on site. Excuse me. And to assist with planning, because it was in a sensitive area, or the house is in a sensitive greenbelt area, we decided, wherever possible, to follow the same footprint of what had been there previously, and also to make sure that the volume of the properties which were constructed, or for which we were seeking planning, were going to be less than what had been there previously. Okay, over to you, Apos.
I'm going to speak a little bit about the design approach we took on the project, and a bit on a couple of elements of the technical aspect of it. As I said before, I'm an architect and certified passive house designer, and I think that it's really important to build something into every project going forward regarding energy efficiency and sustainability. So this was a great opportunity to develop something like this house. So Duck Barnes is situated on the southeast side of Drayton. You can see it on the pin there where it is compared to Cambridge. It's a nice rural area along Park Lane, and the site used to be a farm, and there is the existing the original farmhouse, which is on separate ownership. there is an original or an older barn building here in the center that has been extended with sheds to the north. There is a bigger agricultural barn on this side and a smaller one at that corner. And because before Stephen and Michael purchased the site, it has been used for keeping and training horses. So there are a lot of stable buildings. You can see the smaller ones and a training circle and a menage for training horses. The site is fairly rural, so this is Park Lane. Our site is on the left side of the road. This is, or it was, the site entrance with the original barn building and then the extensions with the stables, very simple constructions out of timber on a brick plinth. That's the view from within the property looking to the east. So that this gable is the original barn, and that's the farmhouse. You can see it also from this side. So this is the farmhouse at the back with the barn and the sheds on the side and all the horse pens and stables. So this is a site plan of what's there or used to be there. The original request or brief from Stephen and Michael was to use the existing building and convert that into something. Once, as a low energy building, that was a bit difficult because of how it's oriented and where the main living spaces were going to be. They didn't offer a great opportunity for making use of solar gains and orientation. And also because when we did a survey of the buildings, damp had impacted a lot, most of them. There were also parts of the buildings, because of keeping animals, they were contaminated with animal waste. So the decision has been made to remove this part of the site, retain as much material as we could. So we were able to salvage a nice amount of Cambridge buff bricks. And other items like the shredded rubber in the paddock has been sold on to neighboring properties that are keeping horses, and they wanted that, unless I'm mistaken on that, Stephen, but I think that was the case.
It wasn't sold on. It was gifted to a neighbor
Okay.
who was moving to a new stable. So yes, yeah.
Yeah. Key takeaway for me is it wasn't binned. It was reused. Because of the site layout and because it's in the green belt, as Stephen said, planning was very particular about the impact any development would have in the green belt. So we got planning permission to develop something on site that has the same footprint, sort of the same volume, and sits in the same location. And we had 27 planning conditions, most of them relating to the green belt and had to do with the ecology of the site, retaining the biodiversity, making sure that external lighting is not affecting wildlife. And I think my favorite was the hedgehog-friendly boundaries, which is a nice touch. But in terms of the house itself, we developed a new house, which is takes into account the public side of Park Lane to the west, the semi-public private side of the farmhouse, and that there's a public footpath on the side along the line here. So this is why we developed the house as a C-shaped form to provide screening from all these public viewing opportunities and have an internal courtyard that sort of evokes a farmhouse courtyard. So this is what the site development came to be. So we have the main house is here. There's the stables on this side have been replaced with a carport and a garden room that's overlooking the garden. And the existing one has been converted into a storage facility, replacing most of its fabric and redoing the floor, but it's not a heated space. So this has retained its structure, and this is completely new, and these two bits are completely new. The house itself is developed as I said, as a C-shape building to provide screening from public views from all around, but also to give the opportunity to provide better solar control on the main house, which is this element. The shape of the roof allows the sun to enter the ground floor fully in the winter, and like this. So this is 21st of December noon arrangement. So the roof allows the sun to enter into the living spaces and the ground floor at the back. And in the summer, the brise soleil that's around that part of the building provides screening from the sun, so it provides adequate shading for that part of the building. But that's also a very good example of how, just by the shape of it and orientation, one can get great benefits from solar control. The floor plan itself, so the house has a gross internal area of approximately 400 square meters. It's developing over two stories and on 3 wings, let's say. The first one is this one, which is usually it's going to be used by guests, has 2 guest bedrooms and with their en suites. It's the main house at the north side, which has the day spaces like kitchen, sitting, TV room, and dining, developing around a core. And then the side element, which is towards the park lane, and that's why all services and plant room and storage areas are on that side to provide some screening and protection from the street, but also to minimize west-facing windows and reduce unwanted solar gaze from that side. The first floor is developing primarily on the house element, on the house wing, which has 3 bedrooms with an en-suite, 3 bedrooms, so 1, 2, 3 bedrooms with an en-suites and a bathroom in the center. There's a utility space, and through that corridor at the back, we'll get into a study that's overlooking down to the entrance area. And there's also a first floor patio accessible from the first floor as well. When we started setting out the house, we intentionally allowed for very thick walls at the planning stage because we weren't sure what the construction is going to be. So we allowed for 500 thick walls when we're designing the house, just to be able to accommodate different construction methods. And I'll show you what we ended up with in the end. So this is a brief video tour. So this is approaching from Park Lane to the main entrance and going into the lobby. So on the left is the services bit with a WC and the plant room through this entrance to the side. And on the right is the guest bedrooms with the 2 guest bedrooms and the en-suites. The dining space looking down to the garden, that's facing east. The stair hall with the lift at the back. And then the kitchen on the side, on the right here. The south-facing windows. You can see the sun not entering the building through brise soleil. Look out to the garden. Yeah, and that's the view back. So that's the ground floor arrangement. So a bit about the construction and services. So this is what we started with. Very quickly became completely empty. You can see the stacked bricks that were salvaged from the original barn. The house is, despite the complex geometry, is simple in terms of what's happening in each surface for this fabric. So the ground floor slab is a concrete raft over 300 mils of EPS insulation with 40 piles going, I think, 8 to 10 meters down at the ground because it's all clay down here. The walls are prefabricated timber Larsen truss panels filled offsite with cellulose, blown cellulose insulation. The thickness of insulation is approximately 350 millimeters. The roof is the same construction, but with I-joists instead of Larsen trusses, also filled with insulation that's 400 thick. The patio, because of it's a thinner construction to enable level access from inside, it has a phenolic foam insulation between and under the joists. All of those elements have a U value of approximately 0.1 watts per square meter Kelvin. The windows are all triple glazed. The large format ones are an aluminum timber composite, and the smaller ones, like the first floor and like these ones, are UPVC, also aluminum clad, all from Internorm. So this is how we started on site. This is right after piling was done. You can see that core deck layer is the heave protection to make sure that whatever movement in the ground doesn't affect the ground bearing slab. But you can also see all the pipe work that was pre-installed and arriving to the house, so services can be incorporated into the ground floor slab. This is pouring the concrete, and you can see all the pipe work sticking out. You can also see a little bit of that rebar waiting for the concrete upstand that will support the timber panels in place. Because everything, I've been showing you images from our 3D model, which was also very helpful to share with the timber frame supplier, which was Timber Innovations in Birmingham. Using our 3D model, they were able to create their own structural model and calculate whatever they need to calculate structurally, and coordinate with our model. And we used that model as well to place the order for the windows well before any wall element was fabricated and being able to survey it. So using CAD and 3D capabilities and BIM made it very straightforward to communicate between different suppliers. So these were the panels when they're being made. So you can see them here laying flat. They've made out of Larsen trusses. So these are basically two skinned studs connected with a plywood flinch plate. They have two sides, the green side, which is the internal side. The green side is a smart ply OSB product, which has the green is the air tightness layer included on it. You can see the blue tape a little bit, probably better on other slides further down the line. And this is all filled with cellulose insulation blown into each panel individually. The panels also are sized in a way that they are easy to handle and easy to offload it and fabricate on site, making that aspect of safety on site quite easy. So this is how then the panels arrived, all numbered, and with their harnesses, they got lifted on place. The house has been assembled. I think it took something like three or 4 weeks to complete the entire shell, and need a little bit of work then after that to become watertight. But yeah, it went up very quickly. What you see here, for example, those blue stickers is the holes where the insulation was blown into the building. So any joints, like where the panels meet, were completed on site using mineral wool insulation, which had the same thermal conductivity as the panels, as the insulation in the panels, which made them practically thermal breach free in terms of the Passivhaus assessment and calculation afterwards. You can see a little bit the structure here. You can see the green side, which is internal. All joints are taped for air tightness. Even joints like this one, which are between panels, were taped afterwards. And basically the steel structure of the house and the timber frame has been constructed in parallel, like a big puzzle. At the same, once the shell was up, services started being added in. This is the underfloor heating manifolds connecting into one place. This is all the ducting for the MVHR, incorporated into solids, into voids in walls. And that was very helpful to have the 3D model available, because we can assess where all those elements went into their building. This, for example, the coordination drawing for all the duct work, with the MVHR sitting down here, the red box. If I see correctly, the green bits is the extracts, and the turquoise is the supply. And that was able to coordinate where everything goes and where it rises, and do we need boxing service voids. So we managed so far to avoid any boxing surprises where a boxing will be required in a place not originally anticipated. A lot of cabling went through the building as well to enable the BMS and the automation, and had to be coordinated with the hot water services, with the domestic hot water and heating pipe work. As you can see what ceilings look like with all the cabling trays. And this is the image of the plant room. At the back, you can see all the cabling terminating into the distribution board side of it. This is the size of the water tank we have in there. Where I'm standing at this point is a very big MVHR, as Stephen said before. But it's you can see the holes in the wall where the MVHR is now connected. But having a space like that was really important. And we ended up getting a bit more from the cupboard next to it to accommodate all the equipment that need to go in. So in terms of the Passivhaus bits, because first of all, we are probably looking into getting into the premium range because of the amount of solar panels they're going to be installed on the south slope of the big barn next to the house. So there's going to be a lot of energy generated, which pushes the building into the premium range, which is great news. This is something that came up in the last couple of days, really. Key takeaways from this is for me that this house is predicted and designed to need 5,200 kilowatt hours of energy per year, and it's 400 square meters. I'm currently in a house from the late 80s, approximately 80 square meters, and I'm using 12,000 kilowatt hours per year. So this is this house, which is 5 times the size of the house I'm in, is using half. It's going to use half the energy, which is really great. The other thing to mention is what Stephen said about the ground source heat pump. So there is an element of cooling also in this building. so the ground source heat pump is going to be used for heating, but also in the summer also to deposit some of the excess heat from the house back into the ground. So it's going to be used for a mild cooling effect in the house as well. We have 3 boreholes of 120 meters depth, and that has been chosen as a system because Stephen touched a little bit onto it. If we had we gone with a slinky system, the surface, the horizontal option, that we would have used approximately, we would need about 1 kilometer in length, which equates to approximately the whole, that big barn size twice. And that would have been really impactful on the green belt. And we decided, let's go for the boreholes because that minimizes what's happening, and in case something goes wrong in the future and one needs to be replaced, it can be done vertically again. Stephen, we did discuss with Stephen whether an air source heat pump was an option. It was, but because it's a very quiet site, we didn't want, or Stephen didn't want to have the sound and the noise of the air source heat pump next to the house. So that's why we went for a ground source heat pump. Here you can see a comparison between losses and gains in the heat balance of the building. And on the right-hand side, you can see all the edges and which became thermal bridges that were calculated to assess the performance of the building. Key takeaway for me, thermal bridges are important. You can see how much they impact. Otherwise, windows is the biggest element for heat loss in this house. We managed to get a fairly decent amount of solar heat gains. And with a slight benefit of all the BMS equipment and lighting drivers that went into the house gave us a nice internal heat gain benefit as well. So in terms of technology, we did use various methods of surveying the site, like 3D laser scanning, which we did either through a station like the one in the photo, which enabled us to make sure the buildings are sitting on the site in the right position, but also that the frame has been erected as designed or within the tolerances set up by the manufacturer. We did have the opportunity to get the robot dog on site to test whether that can be a helpful way of surveying. Which was a good opportunity because the site is big. Yep. And I think ultimately these are all the people that were involved in the project. Structural engineer, service engineer, quantity surveyor, and landscaping were the main people that were designing the fabric and making sure things work. But we also had a lot of input from lighting designers, audiovisual, automation, security. Planning has been greatly supported by arborists and ecology consultants. A lot of joinery items has been done by specialists as well. So it's a very big team to coordinate, which increases the complexity of the project. As a project in general, the energy side of things and the passive house element, I would say probably half or 2/3 of everybody listed here were involved, even from a lighting or an automation point of view. And I think that was my part as well. This is the topping up ceremony when the roof was completed. Yeah, that was all from my end, I think.
Super, well done. Well, so far one question you've already answered. The other is from Mark. Did you consider SIPs?
Yes, we did consider SIPs. So we did consider SIPs. We considered the system that we used, and we considered a more traditional brick block cavity wall, although the cavity was going to be very big. SIPs panels were going to be let me rephrase that. The structure, the steel structure that was needed for the SIPs panels was going to be much more significant than the one we ended up with. And we still have the issue of adding the insulation externally. So having also going for a supplier like Timber Innovations, where they took on the design of the fabric, was also very important, because they were also part, airtightness fell into their brief, and they were the ones guaranteeing airtightness in the end. So the package of airtightness and fabric performance was finalized as a design by the timber frame supplier. So that was an attractive contract opportunity to take on in the project.
Apos's or Stephen's brains on what is a really truly remarkable project. I've got to say, very, very, very. Oh, there we go. When is the grand opening?
Any tips on saving on cost? Says, is there a favourite part of the building you're looking forward to, Stephen? Maybe you can think about the tips while you're thinking of that.
Yeah. I think to answer the first question, Michael and I have specified high-end standard. Well, we've specified high-end items throughout the whole house, and so obviously cost savings could be made in that way. The landscaping could have been scaled back. And again, that too would have reduced costs. As I said at the beginning, a lot of Michael and I set off on this project with a figure in mind. We have exceeded that, but we've exceeded that because of the level of finish and fittings that we've actually chosen. Cost savings could be made by using more competitively priced items. With regards to favorite part of the building, there are several, so I'm looking forward to enjoying it later in the year.
Yes, you'll find out more once you're there, I expect.
Absolutely. Yeah.
If I may, one comment on this cost checking exercise. For me, it's important to design things from the onset and not start doing things and then decide what to do, because doing something like a passive house or a low energy building or any retrofit for that matter is a project that requires coordination. It needs a good understanding of, especially if it's a retrofit, it needs a good understanding of the existing building to see what the existing building can take. So it needs a lot of thinking in advance, be that design or be, research, because all these projects are forward heavy. So the start of the design process or the project journey is the intensive one that has the greatest impact. So if making decisions as early as possible and sticking to them is what's a very good way of controlling cost.
And Mark again asks, why all UPVC clad and not all wood clad?
Alley clad.
Oh, alley. Why alley clad and
Yes.
not alley wood or all wood? Alley wood. Okay, sorry, I didn't understand that one.
So the preface, I think, if you don't mind, Stephen.
No, please do.
Remember those discussions, yes.
Yeah.
The UPVC windows are better performing than the timber ones, but they also have a nicer frame to them. So it's when you open the window, they're sort of frameless. They have some nice detailing to them. They're quite high quality UPVC frames, so there's no concern about their performance. But we couldn't get the large openings in the layout we wanted in UPVC, hence the downgrade, if that's the right term for it, to timber.
And as far as the windows are concerned, we looked at a number of suppliers.
Yeah.
There was nobody in the UK who could supply anything which met the thermal requirements. And it was not just the thermal requirements, as Apos alluded to. It was also the size of the openings, which was causing a problem. I met with a possible German supplier on one of my trips out there, and they had not built windows or constructed windows of the size that we were looking for. So compromises had to be made, and it was decided that we would have a combination of timber, aluminium, and UPVC aluminium to meet the thermal requirements of the property and also the aesthetics of the property, of the design.
Yeah, and I think also the timber windows were able to accommodate not integrated, but recessed blinds. So the large format windows have external blinds that drop from outside the windows to further control solar gains if need be.
Mark says that they're going with internorm. I don't know if that you know those. Are they?
So
Those
these
are the
are all
windows.
internorms.
Sorry.
Yeah.
Sorry, these are all internorm windows.
Yeah, I think that.
Internorm is the manufacturer. They're based in Austria.
Yeah.
Right.
Point to add as well is while we're discussing so far designing and consultant team, it's worth mentioning that one needs to find the right builder for it.
Yes.
So in this project, we went through 2 different rounds of contractor assessments or interviews. We didn't want to complete the design and then get a contractor on board, so we didn't go through the traditional procurement route, but it wasn't also a design and build, it was somewhere in between. It was a 2-stage tender process where we chose a contractor based on their experience and mentality match.
Yes.
And we completed elements of the design using their expertise as well. So that gave some opportunity for cost controlling as well. It wasn't easy to find someone to work in a project of this size, of this passive house and low energy relevant quality, but also quality regarding the finishes. So it was an interesting process to go through, but I think it's worth it as a process. I don't know, how was it for you, Stephen?
David here. Just wondered, we're in a similar position with being partway through building a property at the moment, and we'd be really interested to hear from Stephen what was his worst thing and what was his best thing that he enjoyed about the build process.
Gosh. The best thing, I think, is actually there is no one point which I can say is the best thing. I think I don't know, it's really difficult. It's been a project which has been ongoing since 2020, the middle of 2020, which is actually when we finally acquired the site. And since then, the site has been leveled. It's been prepared for construction. And I think probably one of the most amazing things thinking about it was to actually see the house going up. That was impressive, and to actually, because at that point you then actually realize that the stuff you'd seen on paper or on screen is actually being turned into something tangible. I think disappointment, disappointment, concerning, depression, was when we had the staircase delivered at the beginning of this year. That's something that Apos didn't touch on, but the staircase in the house is a solid concrete casting. That was cast in Scotland and was brought down to Drayton on a low loader. The people who would cast it didn't actually, or for whatever reason, I still don't know why, but they estimated that the weight of this concrete staircase will be around about 3.5 tons. And so Siemens got in a rig which was capable of lifting 5 tons. It became apparent when they tried to lift the damn thing off the back of the low loader that somebody had got their maths very, very wrong. Because in actual fact, the staircase weighed something in excess of 6 tons. And I think probably one of the scariest things was, as it was being taken off the low loader, there was 6 tons of cast concrete actually flexing in front of me. And if that had snapped, and it was possible that it could have done, we would have been back to square one. But it comes back to what I said earlier on about the quality of the site manager we have. He sorted it all out, and it's now taking, I won't say pride of place, but it's now a very important feature within the house. So I hope that answers your question. I wish you every success in doing what you're doing.
Do you want more question? How
Yeah,
important
sure.
was it to use local contractors, you know, wherever possible, local? Was that important to you as well?
I wanted to use a local architect, which is why we chose Archangel, or one of the reasons why we chose Archangel. I wanted to use people as far as possible who knew the area, basically knew the area. But having said that, there are items within the house where we had no alternative but to go abroad or to go elsewhere, go out of area. You know, as I said, the staircase came from Scotland, the windows came from Austria, the doors came from Belgium, toilets have come from Japan. I think the sliding mechanism for the pantry door came from Japan.
It used to be Japan, but I think it's Germany in the end.
Oh, German. Okay, sorry. But yes, wherever possible, we certainly try to use the major suppliers or major partners in the area, because they know what is and isn't possible. But there were some products, some items which could not be sourced locally.
One good example for that is the shutters for the bedroom windows.
Yeah.
So all the bedrooms have shutters that are like visual, at least like mini barn doors. So like solid paneled timber, which they were custom made because there wasn't a product available on the market.
We've had a similar situation. We had that imposed by planning, actually. Yeah.
But we wanted to make use of the BMS system of the house, the BMS of the house, to actuate them when needed, so to control excess heat, for example, in the summer. So it was hard to find someone that can do the shutter plus the automation and the actuators for it and all the driving belts. Initially, we found someone in Latvia, if I'm not mistaken.
Latvia, yeah.
But that was going to be a very tricky arrangement to do. We did find someone in Bedford in the end, and that's what we ended up with.
Yeah, and that's actually worked quite well.
Yeah.
Stephen and Apos for their time this evening. I think it's been really interesting. Libby's just added a link to the chat. So if you've enjoyed this or any of the other Eco Home seminars or webinars or tours, then please feel free to donate. That's I've been obliged to say. So please feel free. But if not, there's a couple of these other talks in the series. So feel free to sign up and remain involved. So thank you very much and have a good evening, everybody.
Thank you.
Thank you. Thanks
Thank
very
you.
much.
Thank you.
Thank you.